Yeah, hi everyone. I am a PhD student at the U of A, and I also work part-time as a narrative designer at Inflection Games. So as you can see here, a lot of people help contribute to this work. Let me see if I can just get rid of that. Yeah, okay. So first I want to provide some context for Nightingale, which is the new IP for Inflection Games. So this is the trailer that's playing. However, the talk is actually going to mostly focus on a game that was previous to this one. So in 2018, about 4 years ago, Inflection started building this game, and it was originally incarnated as an MMORPG. So for this talk, I'll actually be talking about Nightingale as an MMORPG. However, there's been a lot of iteration and development, and Nightingale now is a survival crafting game. So a lot of the stuff, like if you choose to go check the website and stuff, will not necessarily be relevant to this particular talk. I'd first like to talk about a quick overview. So I took the game Nightingale and I actually implemented a quest-based AI director into the game in order to try to provide a better player experience. We then ran an A/B test, and then we found that the results are inconclusive, which matches with this year's theme of Misspun Tales. What I'd like to discuss are some particular outcomes and the supporting evidence of those outcomes, as well as some takeaways from actually working directly with industry. So the first is just the general problem of video games having a lot of different players. Most video games are not adaptive to the different players, so this is a general problem where the games might be more fun and more satisfying if they could actually adapt to each player. AI directors are a class of solutions for this problem. Roughly, they are just different kinds of algorithms that choose to modify a game in a particular way in response to a particular player playing the game. So there's some common applications of AI directors. The first one is to adjust the difficulty to the player's skill. The second is to change the narrative to suit the player's preference. And a third one is to change the quest to suit the player's preference, which is going to be the focus for this talk. Now I'd like to discuss the Nightingale game loop. So players started out in Nightingale City, and there are a couple of different places that they could go. First, they could go to a canonical realm, and then they could also travel to something called a temporal realm. From the temporal realm, they also could go back to Nightingale City. So these are the three main areas we're going to be working with in the talk. In the canonical and temporal realm, there are different kinds of gameplay. So in the canonical realm, there was gameplay that was not available in Nightingale City, but if you wanted to even explore further, you could go into temporal realms that have bigger challenges. In both the canonical realm and the temporal realm, there was ability to accept quests, and those quests could be completed by doing actions in the canonical and temporal realm. Then in Nightingale City, the player could then spend those experience points to get upgrades such as carrying more things. So this is an overview of what a level actually looked like in the game, where players had a portal and they would step into the portal into a realm. Directly on their left, there was a quest board that spawned. So the quest board is where they were able to actually access the AI director. This is a blown up view of what players saw as the AI director. So there's a couple of different areas of interest here. So the first one is actually an area to actually submit quests. So in order the quests were not auto-completed, you had to have a manual action. And here you can see the button of like, this is where they're actually going to submit it. They were also able to select quests. So in Nightingale, players had the option to accept them and also just ignore them. So we weren't forcing players to take any particular quest. In a menu that's not available here, players were also able to just stop doing quests if they wanted to, and they could just abandon them. So now I want to talk briefly about the quest in Nightingale. So the quest definition that I use is the one here, which states that a quest is a set of tasks that are partially ordered in order to, that a player must complete in order to receive some reward according to a distribution. For all of the quests in Nightingale, they were exactly one task. So the first set of quests was going to be our crafting quests. Then we have building quests, harvest quests, and kill quests. And these represent the four main gameplay types that were available in Nightingale at the time. These quests, different amounts of quests, were then roughly balanced, so they would have about the same amount in each type. For example, a crafting quest could have been craft 1 food artifact. A building quest was build 6 foundation structures. A harvest quest was to acquire 10 ore, and then the killing quest would be kill 5 wolves. So now I want to talk about a quest-based AI director design. So there are a couple of design goals as a focus for this AI director. The first one is to support players that actually create their own goals. And then the second is to identify the preferred gameplay and then provide more quests of that gameplay type. We had a couple of assumptions in actually building this. So the first was that the quality of each quest is the same. So the only meaningful difference between any of these quests is the gameplay type. And second, that the AI director was designed for the final version of Nightingale. Now I'd like to briefly talk about the actual AI director algorithm, which is a combinatorial multi-armed bandit, which I've abbreviated here to CMAP. Roughly, it just uses a set of arms and super arms to run a distribution. So in order to actually do quest selection, we need to define what those arms and super arms are. So we can take a quest, and then we can say we have a quest proposal, which is all the quests that are shown to the player at the same time. We can then abstract those quests into their quest type because that's the only meaningful difference. And then we say this abstracted quest type is going to be an arm. From there we have an arm, we need to generate super arms. So super arm is going to be a set of arms. For example, we can take an arm that has at least one building quest, and we can generate a super arm that has similarity to that particular abstracted quest proposal. So we would say that the super arm would be all of the abstracted quest proposals that have at least one build type. Now we need to talk about actually rewarding this arms and super arms, because in other applications of this algorithm, you can simultaneously evaluate all of the arms, but you can't do that in our setting due to the fact we can't just spam players with a bunch of quest proposals. So if we take our quest proposal, we can get a direct outcome by showing that to the player. So we just say, we want to give a reward of 0 if the player does not accept the quest, and a reward of 1 if the player does accept the quest. We also have information from the quest proposal about the accepted quest type, which allows us to get the number of accepted quest types. So once we're able to build out the outcome and the abstracted quest proposal, these abstracted quest types can be used to extend the knowledge that we learned from a particular quest proposal to reward the other arms in a given super arm. So let's say, for example, we have accepted quest types of build and craft. From there, what we do is we want to generate the power set excluding the empty set. So we have a craft set, a build set, and then the building and crafting set. From there, we generate super arms. So for the crafting one, we generate a super arm, which contains all the abstracted quest proposals with at least one craft quest. Similarly, we do that with the build and then with the build and the craft. Note here that if there is a particular abstracted quest proposal that could fit in more than one of these, we put it into the super arm that has the most similarity. So for the actual super arms, we now need to assign a reward. And here we just say it's the number of quests that are same between all the proposals in the super arm. So for the crafting one, it's just the reward of 1. For building, it's also a reward of 1. And for building and crafting together, it's a reward of 2. Now we need to actually talk about proposing quests to the players, because we've abstracted out a lot of things from the real player experience. First, what we do is we take the set of all super arms and we use UCB to select the next super arm. From there, we use uniform random to select a particular arm from the super arm. That gives us an abstracted quest proposal, which we then use another uniform random algorithm to actually select the quest that we want to put in front of a player. Now I'd like to talk about the experiment. So this was done in a playtest for Nightingale. And for the players, we had friends and family of the Inflection development team, and they could also play at any time during a 52-hour window. We had 208 players actually play the game, and from this we did an A/B test where we had 75 AI director, which uses the CMAP algorithm, and then 133 random players. So we're using random as comparison here because it's considered industry standard by my coworkers at Inflection Games. Now I'd like to talk quickly about some of the data that we collected. There is a lot in general that the playtest has collected, but there's just a couple of relevant pieces here. So the first is just overall from playing Nightingale, which is just going to be the total playtime that people play the game. And then second is going to be more focused on the actual AI director, which is going to be the acceptance rate. So that's just the number of requests that players accepted divided by the number of requests that were actually shown to the player total. We also completed a qualitative survey using Likert questions. So we wanted to check if there was a satisfying variety of players provided to the quest. We wanted to check and see how many quests the players felt like they were completing. And then we wanted to check and see if players felt like they were able to actually find the quest that they wanted to do. So we asked the question, was the AI director actually a more satisfying experience than random algorithm? And there are three possible outcomes. First, that the AI director is more satisfying. Second, that the random is more satisfying. And then the third is that there is no difference. For evidence supporting that the AI director was a more satisfying experience, we look at the acceptance rate. So basically, we can say that the AI director has an average acceptance rate where the random is 9. And we postulate that that could be because the AI director was giving more quests that the players actually preferred to do. This result is not statistically significant, though. For the random algorithm being better, we have the actual total playtime, where both the median and average was more than the AI director. So this was statistically significant. There's a couple of reasons for this. It could have been due to the intermittent reward schedule of the random compared to the AI director, where the random was more not necessarily always rewarding what was going to be what players wanted to do. And then the other possible reason is going to be a mismatch between the playtest game and the expected game. For example, the building loop was really well built out and had a lot of polish to it, whereas the kill loop did not have as much development time. So it needed more iterations in order for it to feel a little bit more interesting to some of the players. The last one is that players perceive a similar player experience. So this results rely on our qualitative data. However, there is a hiccup on the back end for everything. So we're not able to actually connect all 208 players to these results. So this is going to be with 10 random players and 6 AI directed players. According to this particular Likert scale, we can see that there's actually pretty just similarity in a lot of them. So even with the AI directed and random for quest completion, they just said it was all the same. So now I'd like to cover a few quick takeaways from working in industry. The first is talking about finding the right industry partner. The second is talking about researching and actively developing a game. And the third is evaluating research on an industry timeline. So I work with Inflection Games, which is a studio in Edmonton. And this work was only possible due to a long-standing collaboration between my advisor, Nathan Sturtevant, and the developers at Inflection Games. So the developers at Inflection Games see the value of academic work, so they have also put a lot of time to foster this long-standing relationship with the U of A. Next, I want to talk about researching and actively developing games. So to actually implement this AI director, it took about a year of development time, and not just from me, there were other engineers that were required to actually build this out. So just to keep in mind when you're actually putting something in a game that's being developed, it is not necessarily going to be as fast as you working alone and your own projects. Last is just a note about industry timeline. So this playtest where we got actual data from was originally supposed to run in 2020, and it did not. It actually ran in 2021. So if you're looking at a collaboration like this, but you have a really tight graduation timeline, then maybe this kind of collaboration is not for you. In my case, it's okay because I'm a PhD student, but master's students with aggressive timelines may want to look at a different kind of research. So thank you, and if you want to have more information about Nightingale, you can check out the website.